So first question on the silver layer. Yeah, go to silver layer. Yeah. Deepesh, how does the PySpark identify the duplicate records here? When we say drop duplicate, it has to apply a logic to identify the duplicates, right? What kind of logic does it apply?
No, but why? It's basically once the can you go above? You read the data. You mounted everything. Okay. Then you are cleansing and doing transformation, right?
Mhm.
So what you are doing there is, see, you need to remove duplicates. So, based on certain thing, you need to remove duplicates. So you have taken diagnosis is not null, and you need to take which column based on cost. You need to create another filter of rows with missing diagnosis. Okay, so you need to create a kind of a new column of cost in which there is no null. Sorry, where there is null. Okay, and you need to based on this average cost you need to do. So there are some certain changes you required, I believe so. So that is the best way, and then you will save into that. So let me share you. Uh, you can write in this way, like you need to drop the temporary average cost column, and then you will drop the duplicates.
Okay, I'll try that.
And mhm,
So initially saving the raw data in the raw data file and then loading it to the branch layer, displayed the branch layer,
okay.
then filtered out the rows. So I did in the silver layer, I did each step segregated it, and I did it like first I filtered the not null values for the diagnosis column. Then average cost per consultation, giving the aggregate function using that. Then the missing values, I filled it using the when and otherwise. And I use this drop duplicates to drop it, but as discussed now, I'll try to make
I'll share
changes
the
as we
code for
discussed.
that. That's not a problem for that part.
Mm.
I'll save.
Then saving it to the silver layer, and then loading it for using it for the further actions. Then I joined the doctor ID, doctor data frame with the silver one, and then since there were null values, only 2 rows I was able to fetch.
Mhm.
Then till here I did it. Since there were only 2 values, so I did not. I calculated the total consultation. I was not able to. I just moved the average cost only to the total cost. But was how did we have to fetch it?
So
Total
you
cost.
can do, you have enriched the data using gold above based on doctor ID inner. We have joined
Still,
how we joined
the
here
doctor data
and
frame I
doctor
created.
ID. And can you make it inner join,
Here,
comma after doctor ID? No. Use the comma inner. No. Just after the brackets of doctor ID, enter the comma inner in quotes, just to
Okay, I just terminated. I need to start it.
No worries, no worries. So here, and then you can find out, aggregate the total consultation cost by doctor and by specialty. You can find those things.
Okay,
Or you can, you know, in golden layer, then you can save later on. So
sure.
for the silver layer in which you are doing dropping the duplicates, you can do just let me
Here.
that is done using.
So if we are doing only using this function like drop duplicates, how is it different from the one that you will be sharing? Like, what is the
No,
different
no
action?
difference, no difference. Just we are doing window partitioned by
Hmm.
the, so you haven't used window partition, right?
No.
So when we do window partition by doctor ID, so the average cost per doctor first calculated, then I calculate the average cost per doctor, and then I'm cleaning and transforming the data. So by
Okay.
drop duplicates only. So just a second, let me. Yeah. So, first of all, when we talk about the optimization for performance, okay, so there are certain, techniques that we could have look into that. First of all, see, instead of using RDD or creating RDD, we can create, first of all, data frame instead of creating an RDD. So generally nowadays, even though we are majorly using data frame only, because RDD is slow than the data frame. Okay, the efficacy of data set is even lesser than the higher than the RDDs, but data frame is faster because we are using PySpark. So data frame maintain the structure of data and columns like in our PySpark data frame or RDBMS table. So this handle in a better, manner. Okay. So for that reason, first, that is the one thing that you can actually look into that. So let me write here one by one, and then I'll tell you some of the examples if we can. Yeah. So the very first technique that is we can use, data frame over data set. Okay. Or over RDD, you can say that. So data frame is the best because it's having a complete structure, okay, complete structure of rows and columns, okay. So Spark jobs prefer data set than data frame over RDD. Data set and data frame includes several optimization module like to improve the performance of a Spark workload. And for that reason, data frame over RDDs uh, and data sets are not supported by PySpark application. So Spark RDD is a building block, but if you are making your data just in RDD and applying this, will not so efficient. Okay, so Spark RDD is a building block of Spark programming. Even though whenever we are using by default, it's internally creating or using RDD to execute operation, but the efficient and optimized way of for analyzing your data, okay, for queries and creating execution plan, then we can go towards the, creating into this data frame. Okay, that is the one thing. Next, when I talk about the, like the processing of partitioning the data. So, when we talk about the partitioning of data partitioning, so we can partition our data. So basically, whenever we are partitioning the data, we need to ensure that data is distributed evenly across the cluster. Okay, all the cluster, it should be properly, distributed, and the distribution. Okay, the proper partitioning help the workload and reduce data shuffling. So when we do a proper partitioning, it reduce workloads and data shuffling. Okay, and that is why it's improved the performance. Okay, so for that reason we can use repartition or callsec function. So with the help of this, we can control the number of partition. We can control number of partition. Okay. So typically partition happen into 128 MB in size, and that is how we can partition. So using the function called repartition and colsec, we can actually like partition the data in a proper manner. Got the point? Hello.
Yeah. Deepesh, is there any restriction on how many partitions we can do?
How many partitions we can use?
Yeah.
We can use as number as partition, but depend on your cluster size, depend on your like how much the data or the accumulacy of your cluster is there. So that also depend, uh, you know, and also uh, it depends on your input data. Okay. So when you are having input data, you are reading data to create partition somewhere in 128 MB. So while you are configuring, uh, within the help of repartition or cold sacking, so based on your cluster resource or your task size, so task size generally what I can recall is somewhere around 100 MB to 1 GB per partition. Okay. So we can adjust the partition according to the size of the data set and the available cluster resource for optimal performance.
Like, is there any ratio like for this amount of cluster we can process this kind of amount of data, this much a size of data?
Mhm. Yeah, that's what I'm saying now. The average, default block size is 128 MB of input data. Okay.
Right.
So when you're partitioning, when you're configuring using repartition colsec, you can specify those number of partition based on, you know how much data you are having and based on the cluster resource and the task size you wanted to define. Like I give you one example. Let's say you have a text file. Okay. And by default that SDFS block size, the text file is there. The file size is, let's suppose, 512 MB. Okay.
Mhm.
Let's say the file size is 512 MB. So the SDFS block size, the block will be of 128 MB.
By default, yes.
Yeah. So Spark will create 4 partition. You can create 4 partition
Mhm.
of MB 512 by 128 will be 4.
Yes.
Okay. So that you can define. So when you are reading this data, let's say you're reading this data, okay, let's say in sc.text file, whatever your path of data into, you know, uh, you can pass the number of partition here in whatever the partition size you wanted to give. So you can define this. Okay. Or if you want to create into 8 partition, you can do that.
Mhm.
So that is
Dipesh, I have a question, right? So, can you please explain based on example where we have 100 GB of data and just consider any cluster size. You can create any cluster size that 4 nodes are there, this much cores are there, right? And this much memory is there. With that example, can you explain us like how to find the ideal partition, right? Or how to kind of go about finding the right partitioning of data while processing?
okay.
Yeah.
Just throw me some example. Okay. So let's say, okay, let me just see. First of all, if you are aware of not, there is a formula of optimal partition. Okay. Are you aware of that?
No, I'm not aware.
So the formula of optimal partition is The formula of optimal partition is that the number of partition you are trying to create is first the number of executors into the number of cores per executor. So you select the cores, right? When you're creating a cluster,
Yeah.
right? Multiply by 2, or you can use 3. Okay. So the factor 2 or 3 ensure that there are enough tasks. Okay. This ensure that there are enough tasks to keep cluster busy and finish at different time. So that is the formula. Now, this is the ideal solution. You should have an idea. So when you are defining, let's say you should know what are the number of executors each task per core you want to define. Okay. Number of CPU cores you have, memory and data size, input, output, throughput. So these understanding you should have first of all. Okay. So the ideal number of partition in Apache Spark, considering the fact of these things, okay, by considering the fact of these things, and let's say you have 4 executors and 5 CPU cores per executor. Okay, so based on the formula, the number of partition will be here. Number of partition will be means
40.
executor multiply by 5 cores multiply by 20 equal to 40 partition. Can you see that?
Yeah.
Yeah.
So 40 partition will be there.
Yeah. So Dipesh, just want to add here. So for example, we have very large amount of data, right? And if we create 40 partitions, right, of that particular data, and for example, we are processing 400 GB of data, right? We do 40 partitions, right? So one partition will be of 10 GB, right? And that doesn't fit into your core. Sorry, yeah, it doesn't fit to your core, right? So we'll also have to consider the size of data in the formula, right?
I
Yeah.
already mentioned, na?
Shall I
So how
repeat?
would you decide the number of executors? How would you decide I already mentioned first in the beginning only that input output throughput is also there. Like when we are, memory and data size I mentioned. So here I mentioned this. Let me tell you what all the factors is there. Number of executors, number of executors, number of CPU cores, CPU cores. Third, memory and data size, and data size and input output throughput. Got it?
Yeah. So
So
can you give some numbers to all these, and can we, understand with a live example?
so number of partition, let's say taken up here 4. So executor, how many executor is here?
Let's suppose 4 executors.
4 executor is there. 4 multiplied by cores are 5
Yeah.
multiplied by 2 equal to 40.
Yeah.
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 So this is the baseline for fully
Okay.
utilize cluster resource.
Mhm.
Now computation might be based on factor 3 or 2 also, and this can be repartitioned accordingly.
So, Dipesh, what I am saying, can we, try to understand the right partition based on these configurations for 100 GB of data? Let's try
So
to see, like, for 100 GB, what will be the right kind of partition or how to go about it.
See, if you have 100 GB of data,
Yeah.
see,
And let's also give some number to the memory, like, how much memory will come in each core.
See, Deepesh, in this case, if you consider 100 GB of data, it will be like more than 10 GB per partition, right? So what Rajit is asking, what is the ideal size? If the data is more, what are the clusters that what should be the cluster size to
Not
handle the data efficiently?
cluster,
Yeah,
but I am
cluster
asking
size is
like
also there.
what should be
And the
the
partition
ideal
size.
Hmm.
size of partition? Yes.
Yeah.
How to go about the right partition in this
Based
scenario.
on the size.
Yeah.
So the common guideline is to aim partition between 100 MB to 1 GB for smaller partition. For better parallelism, we reduce, there is a reduce overhead we do. Let's say the target partition is 200 MB for each. Okay. So if you have 10,000 MB, okay. So, and the target partition that you are assuming is, let's say, called 200 MB. Okay, so you can consider the target partition is 200 MB and your input is, let's say, called 10,000 MB. 100 GB is 10,000 MB. So you can consider this as a divided by 200 MB, somewhere around 500 partition. Okay.
That also depends on the, the
And
configuration of cluster.
if you are taking the cluster size also, in which you have, let's say, called 5 executors
Yeah.
or 4 CPU cores.
Yeah.
Okay. So the number of partition, um,
No, what I am trying to say, it depends how much memory each core has got, right? Each core, if it, if our cluster is 32 GB, right, and there are 4 cores, right? So each core will have 8 GB, right? So based on that, we have to partition, plus also we have to consider the overheads,
cluster is
right?
32 GB
Yeah.
and
No, I'm saying one node is 32 GB, right? And how many 5 executors we have considered, right? So we can divide 32 GB by 5, right? That amount we'll get in one core, right? Then also we have to understand, what are other overheads, right? Because like for example, if we get 6 GB per core, 6 GB will not be used because there is heap memory and other overheads also.
correct.
So I want to understand, on all that, overheads also.
Yeah, I mean, the in detail execution for this, there are multiple other stuff is to be discussed. Let me just proceed one by one. Okay. So because others may not be able to understand. So that's why let's discuss what all the optimization process first, and then I can take an example, and then I can discuss this on the top of it. Okay. Or I'll share you some resource where you can look into that, this thing. Is it good enough? Who is asking this question? Mr. Arsud?
Yeah. Yeah.
Yeah. I'll share you some documentation, a detailed documentation of partitioning process based on the cluster size and memory on heap and all, right? That will give you a better idea. Good enough. Yeah, moving further, as I mentioned here, the first technique you can take up is, like you can use data frame, the better partitioning process you can use. Okay. And then, apart from that, you can have, apart from that, you can actually look around this process of broadcasting variable, caching and persistence, wide transformation, those kind of techniques you can use that. So yeah. So also in partitioning, I think if you are aware of skew handling, Mr. Arsud? Hello, would you like to discuss what is skew handling? Hello. If I'm
Skew
not able.
handling, I think it's regarding to distribution of the data. I don't know exact explanation for this, but it is related to data distribution, how the data is distributed and how we can
Skew
handle
handling
it.
is nothing, but it's kind of if one partition, if while we are doing, if one partition has significant more data, okay, then others can correct? Slow down the job. So we can use custom partitioning. We can use custom partitioning based on keys or even repartition the data based on key distribution to avoid the skewness. Okay, that's called skew handling. Got it?
Yeah, Dipesh, one question here. So basically, you are saying ki on a particular partition there is more load of the data, right?
Mhm.
That is why we need to do the skew handling here, right? By
Yeah.
leveraging the custom partitioning, right? So how we can do that exactly?
How we can do that exactly?
Mhm.
No, so we do this. The process I have told you a bit, understanding I told you, we do using repartitioning.
Yeah, yeah. Okay.
Okay, we do using like the way I have told you, repartitioning. So
Right.
that custom partitioning or with even repartitioning, we can do this process of skew handling. Okay, that is the one way we can do that.
And
That's
Dipesh, how we will understand whether the partition has significant more data and it is taking a time so that we need to do the repartitioning.
see, first of all, like when you use the Spark UI also give you a lot of things. You can see the, a lot of feature of that from there also. Uh, you know, uh, so that is the one way. Uh, and how we actually solve this problem of skew handling is, while we are making any inferences for that. So when the data are distributed, how we are identifying based on the number of records in per partition. So for this, there are some concepts of map partition. Okay, there is a concept of map partition based on some indexes, based on some iterator, or we can collect the partition size and then we can use partition size dot collect. So that's how we'll get to know about these information. Okay. Or you can see into the Spark UI when you do a task completion. So whenever a task completion happen, so you see the time. So in Spark UI, there is a certain significant task taking longer time. So that it will help you also to visualize. So the one way by UI and the one way by using mapping the partitions, mapping the partition, or then finding the partition size also of size. And then you can collect for this. Hello.
Yeah, Dipesh.
Dipesh, I have one question. Uh, Partitioning is fine, but the partition will happen based on the input data, right? So in that case, we have from the input data, we have to identify a column which we have to use as a partition, correct? So how do we find the column which can provide the optimum partition value, right? So suppose it's a date column, or how do we decide that which column we can use for partition?
No. Partition happen throughout your partition is what? How you are taking this partition? Partition is the complete data. It is not the partition of any particular column.
No, I
Partition
got
happens
it. I
to
got it. But to divide the like partition is creating different what you say,
Segment.
kind of yeah, segments, right? Fragments. So to divide that fragment, we need some column from the data where it will tell that okay, this segment of data should go to this partition, or this segment of data should go to this partition, right?
Uh,
So how do we decide that deciding factor of which column we can use, and based on that we can do the partition and store the data?
I think Mayur, partition happens on the row level, not at the column level.
Yeah, I understand that, but uh, based on what you will do the partition is my question.
Based on the memory, based on
Based
the
on
size.
size only.
Yeah.
Okay. So it is happening based on the size of data. So let's say you have SDFS data and the block size of that SDFS data is 128 MB. Okay. And you have 1 GB of file. So that 1 GB of file will split into 8 partition. Okay. And
Okay, I got it, I got it.
So
So this is
I
like
just
auto
want to,
partitioning of the data, right?
so I
You're
want
saying.
to add here, you can, partition the data randomly, based on rows or based on size. You can also partition based on rows, sorry, column, Mayur. And the answer for your question is, I think, high cardinality. For example, my data has sponsors, right? Sponsors is something which has high cardinality, right? So one sponsor can have, like, for example, if my data is 1,000 rows, right? So one sponsor can have 250, other can have 250 rows, right? So we can partition by sponsor column, which has high cardinality. Yeah.
Also, like when deciding partition, we have to do we need to check like how the data gets segregated if we do that partition, to
Yeah,
so
we
that
can check.
the
Yes.
skew doesn't appear, or it does not happen?
Yes, that's one factor. Also, we can check on, how is the data used, right? And this is especially when we are writing the data, right? When we are
Yeah.
writing the data to data frame, we can partition by some columns, right? For example, date column, sponsor column, right? And depends how the data is fetched. If data is fetched more on sponsor and date, then we can use sponsor and date as the, partition.
Partition
Yeah,
columns.
yeah, yeah.
Okay, okay, fine. Okay, thank you.
Yeah.
Also, Dipesh, can you share that formula thing that you explained, right? That to decide the partition, the executors and all. Can you please share that?
I don't have any document for it. Just I remembered. So can you write it down?
Yes, yes.
Hi Dipesh, I have one doubt.
Yeah, Nikhil.
Let's say like we created a raw layer and we partitioned by maybe country column, okay, means state column something, okay, and there all data are evenly distributed over each state, but one state has little bit more data. Okay, we consider that as queue, right? So now next is like we'll face the problems. Okay, means like slow running execute, all those things will face the problem. And now if we do repartitioning here, already partitioned, okay, in the raw layer, and now we are doing repartitioning, apply, if you apply repartition, then what will happen? Means like means all the partitions of, means all the state partitions will get shuffled, or like only few of the states column will get shuffled. And so how that shuffling will happen? It will completely shuffle all the data to group to particular number of rows, means block sizes. So what it will do? Because if you have very huge data, right, and you are already partitioned, still if you do repartitioning, everything should be shuffled. Is that will happen?
That we talk about white transformation, right? And white transformation you're talking about like
Repartitioning, specifically repartitioning. A white transformation, it will happen. But in repartitioning, I'm specifically focusing on repartitioning. In coalesce, what happens is each of the partition will reduce, right? Well, repartitioning, I saw like it will do shuffling across everything. But like till
based on raw distribution, you can do that. Let's say if your after partition ID assigned, So you can do row distribution, right? So whenever after partitioning IDs are assigned, so Spark actually begins the shuffle process, as you know, right? Like based on map, phase, spill, shuffle right. So you are asking what happened when we talk about when the data are not shuffled and how it will happen after reshuffling, you're saying, right?
No. See, like first, you can consider, let's say we have a 2 GB Parquet file, okay, and we don't have any partition there. We are loaded to the raw layer. While loading, it created automatically, dynamically created some shuffle partitions, and it created some around 200 partitions. Okay, now means based on the column, what maybe country column. So in the raw layer, we have already partition data. Now we are using going to the silver layer. While in that, we are seeing like one of the partition has more data. Okay, means one of the state has more data. Let's say like Pune. Okay, that state has so much data, and other states have very less data. So now Pune, I faced the issue. I through this Spark UI identified this was the problem. Okay, and I obviously salting will work here. It will work. Skewing if you apply it will work. But I'm just focusing on the repartitioning part because repartitioning also works here. That is also one of the other solution. And if I do repartitioning, okay, already there are a couple of partitions of states. If I do repartitioning and only one state has more data, now what will happen actually? If I apply repartitioning, everything will get shuffled, or what actually inside that will happen if you
See, the inside way of shuffling, oh sorry, repartitioning is, it's create a new partition, first of all. So whenever you do repartition, Spark assign each row a new partition based on the desired number of partition. Okay, so we can use hash function. If you're aware of hash function.
yeah, hashing I'm aware of.
Yeah. So then it's create a map phase. Okay. So each partition determines where its row should go by creating intermediate files. Then the shuffle write happen. Then shuffle read happen. Then rebuild partition happen. So data reassemble into that. Now you're asking how this structure will look like inside that. Okay. So like your question is based on some scenario. So let's say I have just taking one example. Let's say you are taking not taking much file, just a small file. So let's say when you are talking about a partition, you have the data called let's say call some basic value, any small value, okay, and you have two data, let's say called two banana, something like this, and you have more partition. This is in partition one. The data is let's say residing in partition one, okay, and in partition two you have more data. So in partition two you have let's say called cherry, you have date, you have something like that, okay. So now if you want to partition the data into partition three, okay, partition three, repartition three, let's say call three. So, it will create the hash function. Spark actually applies here the hash function in this process. Okay, so it will go by hash one to partition zero, then hash two to partition one, then partition one, then hash two like this, then it will go hash three to partition two again. Okay, and then in the hash four again it will go for zero because it's assigning a new partition. For that it is shuffling right based on old partition data, correct. So from one apple, like in we had one apple, it's from the partition zero, two apple from the partition one. The partition two have cherry, date, grape like that. So that is how it's create, and it will create their new partition out of that data. So like in partition, when the every time when the partition happening, rows have redistributed across new partition every time, okay, and some datas are going from all of them, from partition one, two, three like that. So it redistributing across all the new partition with suppling whenever you are doing. So whatever data you have, it's 100 GB or something like that. It actually based on some hashing process it's taking. in underlying way. So that is the idea. That is the idea of partitioning, shuffling happen on any kind of data.
Okay, for the hash function, like which are the column it will consider so that it
So like
can.
1, 2, 3. So let's say if you assign a new partition, so it applies. There is a hash have a certain configuration that I don't have right now the exact idea. So there is a certain configuration of hash function, and accordingly it's processed.
Okay,
So yeah, I need to get back to you on this.
thank you.
So I discussed two things as of now. One is the RDD, then partitioning, and then I told you in partitioning this skewness of data that is also there. Now in skewness of data, once we talk about the skewness of data, then there is a concept of caching and persistence. So what is caching? Caching of help you to reusing the same data frame multiple times in a workflow. Okay. So if you are use df.cache, you can use it. Or you can store also like df.persist. Do you know the concept? Nikhil, can you please, because you're aware of these things, I believe you can explain. So please tell me what is df cache, how df cache work and df persist work.
So cache will store in memory if let's say data frame we are reusing many times, and then we can cache some of the data frames so that we can reuse. And persist will give more options. Cache will always store in memory, but in RAM, I mean, and persist will give
Are you
other
sure
options.
it's
We can.
always stored in memory?
Yeah, cache will store in memory. Persist, we have memory only and other options, right? So we can store in other places also. We can use disk plus memory, and those options we can use it
So what are
persist.
the storage level of caching or persistence?
In memory and disk, only memory, disk plus.
We can store in memory only or memory and disk. So both is the option.
Yeah.
So I believe everyone understood caching or persist is the method by which we can reuse the data frame multiple times in a workflow. Okay. So that is called df.cache and persist. Let me write in a better way so you will understand.
So basically, instead of loading data multiple times, we can cache the data frame and use it anywhere we want
Yeah, if you want to reuse the same data frame multiple times in a workflow, we can use this.
in a workflow. Okay.
Then there is a concept of broadcasting.
So, Dipesh, on cache and persist, right? You are saying if we cache in memory, we can use it multiple times, right? Basically, in Spark, everything is in memory only, right? So, what is new about this?
This is you need to apply. So when you are doing caching, it's nothing but whenever a data set, Spark actually materialize the data. It's compute and stores basically. What you are saying is Spark materialize the data of computes and storage. So whenever the first action is triggered throughout the Spark, we actually, you need to call it. So when you're calling the cache data set, we are using the stored data instead of recomputing it, that particular spark that has to be compute that process. So that is the meaning of this caching, that you have to invoke that, you are invoking that particular process.
So basically, lazy evaluation and action, right?
We can say that. And let's say if you don't want to utilize it, you can uncache this also. So if you don't want that to be engaged, that you uncache it as well as.
Can you
So
please talk about lazy evaluation and action so that others are also
Lazy
of
validation we
the
have already discussed in detail. I think you
no,
are in.
with
Yeah,
respect
during RDD.
with
Yeah,
respect to cache
we have
and
discussed.
persist.
Huh?
With respect to cache and persist.
Okay, so basically, if you remember lazy evaluation, I told you that you know, in caching whenever happen, okay. So the key concept of lazy evaluation was because this Spark is written under Scala, okay. So there is a concept of lazy evaluation in Scala is also there, and as well as in Apache Spark. So Apache Spark lazy evaluation, the concept of caching to optimize the performance, okay. So lazy evaluation, it does not execute the transformation immediately using map or filter. Instead, there is a two thing. Okay, instead of that, such as there is a concept of lazy evaluation in which we count whenever we do count or when we do collect or whenever we save is called in lazy evaluation. So the execution plan into this RDD or data frame is Spark does not perform any computation right away. Instead of this, it's create a DAG. It's create a logical way, right? That we have already discussed. So it's when it's creating a logical way of DAG or when it's have a constructed plan or execution plan that how it has to do. So what thing it has to call. So this plan includes all the transformation that have been applied, but no data is actually processed until any action got triggered, right?
Yeah.
You are aware of that?
Yeah.
Yeah. So when we talk about caching with lazy evaluation, so first, when we triggering cache, so caching does not trigger the actual computation on its own, basically. Okay, caching it does not triggering the actual computation by its own. Instead of that, the data set is cached only when an action is executed, basically. Like if we take an example, if we cache a data frame or RDD, but we do not perform an action, okay? So Spark will not compute and store the data until other further process will, we are triggering any cache or not, okay? So when I do cache, okay, or persist, okay, we are telling Spark to keep that data in memory, okay, or another storage level. Okay. So after it had been computed, okay, after it had been computed, it will do the further stuff, means uh, caching itself, uh, kind of a transformation, okay, because it is asking you to store this. So, and it will not trigger any computation. The first action, that uses the cached data set triggers, and the computation will populate the cache only. You know the concept?
Yeah.
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 So that is how it's happened. So whenever you have any data, so you'll see you're reading a data, you read the data.csv, you have any data.csv, let's say. So whenever you're doing df.cache, okay. So at this point, there is no computation is happening. You have no computation happening. Okay. Because cache is a transformation. Okay. Cache is just a transformation. Now, once you trigger the df.count, okay, action triggers computation and the caching will happen. So when we do df.count, it will compute the data and store it in the cache. Then we filter, if you perform another action like df.filter based on some conditions, showing some operations. So that faster execution will happen based on that.
So I was saying something else. I'll just tell what I was saying, right? So, what happens, right, for a same data frame, if we call action again and again, right? So what will happen? Each time we are calling a action, a DAG will be created, transformation plan will be created, and each time that transformation plan will be executed whenever we call a action, right? So to make sure and to not let that transformation plan execute again and again, if we cache the data, right? So we can use that cache data, right? The transformation plan will not run from starting. So yeah, that's one benefit of
You could have
cache.
asked this question directly, this part.
Why I told, right? Lazy evaluation action, right? So that's the only thing,
Evaluation
right?
concept and action concept we have discussed 2 times. I think if you were
Yes,
in
that's what I know you have covered it, but Dipesh, what I was asking was, action and lazy evaluation with respect to cache and persist, right? How cache and persist helps in lazy evaluation was my question.
Yeah, so please try to ask the actual question because we have a limited time, okay? And we need to cover a lot of things. If we just take 20 minutes just to discuss one concept, you know, we'll out of time then in that case. So,
I asked the same question, Dipesh, but you went somewhere else.
okay, no worries.
Okay, we can cover that time in next session. Go ahead, Deepesh.
Yeah. Uh, moving further, as I mentioned that we have, uh, you know, like we tried taking the involvement of other optimization part in which we have broadcast variables and all. And apart from that, different other joins techniques are also there. Oh,
Deepesh, we'll ask you a screen sharing.
okay. Yeah. So moving further, there is a concept of broadcast. Okay. So if anybody would like to highlight what you are aware of broadcasting.
Broadcasting in general.
Okay, so I thought, see, there are something that we can look into related to broadcasting in terms of uh, optimization of your Spark evaluation or Spark processing. Okay, so broadcasting is a concept. Broadcast when we are working on a small data set. So whenever we performing joins, okay. So when you are doing, so that's something that you can look into that when you are doing joins. So joins between a large data frame and a small data frame, small one. So broadcasting the small data frame using broadcast will ensure that the replication will happen across all the nodes. Okay, so replication will happen all nodes. Okay, and it will avoid shuffling in that case to avoiding shuffles. Okay, so that is the concept of broadcasting. Okay, so broadcast join or broadcasting is a concept by which we can also look into to optimize this process. So in Apache Spark, whenever the large data set you have, or distributed large immutable data set you have, and such as you can a large lookup table. Okay, so you have a large lookup table or a configuration data, you wanted to do to all executor so that each worker nodes can access it locally, then this basically avoid the need of shuffle, and we do broadcast join. So broadcast join actually create a broadcast variable. Okay, then the distribution happen. So broadcast variable holds the data we want to distribute. Okay, whatever the variable we have, and then the distribution will happen. And so and then the each executor can access the broadcast variable locally. Okay, when we use this broadcast join, okay, there is this broadcast join when we use, when we have relatively small data sets. Okay, and then we need to join with a much larger data set. Okay, then we use this broadcast join. Got the point? Hello? Hello.
Yeah, Dipesh.
Yeah. So when we relatively a very high amount of data set and a small amount of data set, there we can look into that. Okay, we can utilize this types of joins also. So that is the idea. Means let's say relatively, we access the broadcast variable in RDD operations, then we broadcast variable using data frames. So that is the large and small data frames when we are doing. So then we can do, let's say you have a value of large data set, you have a large data frame, and you have a small data frame. Okay, so you can do large TF dot join broadcast the small df based on their key. So you can define this, and it will process the faster execution. Faster execution. So that is why. If you have any question on this, you can ask. Good enough?
Any questions, team?
No, no, no.
Okay. Then, another way by which we can increase the performance is by avoiding wide transformation. Avoiding wide transformation. Okay. So when we talk about in order to avoid the wide transformation, Nikhil has asked that how we can minimize this shuffling. Okay. So when we avoid the wide transformations, minimize shuffling, operations like join, group by, distincts cause wide transformations. Okay. What is wide transformation, Nikhil? Would you like to quickly give some input?
Yeah, when we are joining the two big larger tables, right? So let's say already partition information is there. Each partition one worker will take, and like let's say like we are joining based on the key, and in another worker that key is existing, so it can't join, right? Then it has to ask another worker. So do you have this key? If it is there, then it has to get the data to perform join. So similar to this, all the workers will be talking to the other workers. So that is, and later, so that they can do join, actual join. So that is the actual means that is called as white transformation.
Okay, anyone else would like to speak up on why transformation?
Dipesh, the concept that you said is slightly different from what Nikhil said, right?
A bit. Basically, it is kind of the idea is said. But see, what is wide transformation? Let's understand. See, wide transformation, whenever we have operations like join, group by, distincts, these cause wide transformation. And this result in data shuffling between nodes, basically. So Apache Spark wide transformation basically refers the result of shuffle of data, okay, across different partitions. So we have wide transformation and narrow transformation, okay, narrow transformation. Okay, so unlike in narrow transformation, what happened? It's involved data within a single partition, whereas wide transformation required data to be redistributed across the cluster, which can involve the network and disk input output. So when we do wide transformation, when join, group by, distincts, it is actually coordinating with multiple nodes and cluster, and then it's shuffling the data. Okay, because it's shuffling the data, wide transformation, exchange the data between different partitions. And that's why it became expensive also, because it's coordinating with different network input output stuff. So we should avoid this wide transformation technique. Got the point?
Yeah. That means we have to keep the uses of group by distinct join, have to keep them minimized. in our
minimize.
code base.
Yeah, yeah. Rather, we should try narrow transformations. Okay.
Okay. How do
So
we use narrow transformation?
narrow transformation is any, a transformation which keeps your data into, one single, kind of a record, like where is not, shuffling is not happening, dependency is less, like when you're doing a sequence of data, when you're creating sequence of 1, 2, 3, or your value is mapping. So, like map, filter, union, map partition, these kind of thing is a kind of a narrow transformation. Shufflings are not here happening. So, yeah. Yes, we were discussing. You were saying, Nikhil, something?
Yeah, I got the answer for that. I had the one question like, is broadcast join? We are sending the small table to the all the workers, right? And
Yeah.
bigger table based on partition, it will do a join.
Mm.
So I was thinking that was a narrow transformation, but it was actually wide transformation. I just got that information. Yeah,
Okay.
I shared over chat. I got the answer for that.
Mm. Now moving on the top of it, here we have, discussed we should avoid the, transformation, wide transformation. There's one more thing, if you are aware of not, data serialization. Mr. Arsu, you have any idea about data serialization techniques?
No, no, Dipesh.
Okay. So what is data serialization? Basically, I don't want to touch that topic, but just giving you a basic info because it's a very, serialization process of, how the datas are optimizing based on cryoserializer. So those are little based on the API side and all. So basically, when you are reading the data, okay, and in Spark and in general with this Databricks and all. So what happened? The process of reading that, the faster objects when the data getting transformed. Okay, so data serialization transforms the data into some format that is suitable for storage or transmission over the network. Okay, so data serialization is a kind of a so I'm talking about data serialization. So data serialization, right here. Okay. So data serialization is the context of Apache Spark that refers to the process of converting data structures or object into a format that can be easily stored, transmitted, or reconstructed. Okay. So in the process of serialization, um, you know, it's a kind of a crucial for Spark because it's enabling it has to enable the efficient data transfer between driver, driver, and executors. Okay, and executors during shuffling or caching process. So whenever we are doing this caching, shuffling, so a proper best way to transfer the data into certain format, that is the part where we talk about data serialization. Okay. So here, when you're configuring, like the process of tuning the data serialization, when you're talking about how to the best, so there are different serialization process, like one is called cryo serialization. Okay, so cryo serialization is a default Java serializer to transfer the data. Okay, for any faster object serialization. So whenever two faster object need to be serialized, then we can use this cryo serialization. Okay, so then there is a Java serialization, cryo serialization. Then you can set. So whenever you are doing a Spark config, na, so here you can read a better which one is the best. So when you do Spark config, you can set that we are using is Spark dot serializer. Okay, then you can use org dot apache spark dot cryo serializer, something like that. Okay, or you are using, you can use whatever the serialization you are doing. So you can actually look into that. So you can, it's basically converting the objects into byte, a byte string. Okay, so that is what.
So Dipesh, what does it actually converts? A data set or a data frame into objects in serialization?
What?
So what does this serialization actually converts? A data set or a data frame into objects?
Basically objects, whatever the data that need to be transferred to the, executors and all. So those things being sent, like what is the work that need to be done. So any data, it's convert the data into byte string. So for storage transmissions, so of course the data that we have, that's something being converted.
Okay, whatever we want to perform or the executors will execute, those
Correct.
will get converted into
Yeah,
objects.
yeah. So that is one thing. Then there is a concept of uh, you know, tuning Spark configuration pattern parameter. So we can tune, like you can Spark executor, you can save into memory size, you can you can do default parallelism process, you can execute the core tuning, those kind of thing you can use that. Then of course uh, here you can tune the Spark configuration. So Spark configuration itself will do a multiple optimization process. Okay. And you can execute or core tuning, you can do that. You can use Paraquet file as we have done, or some other methods are also there. So when you use Paraquet or ORC format, these are efficient for large data sets. So when you're using .paraquet file, okay, try to store into that. So that is efficient, but because it's in a distributed format and all. And we eliminate the unnecessary stuff. Okay, unnecessary stuff, like you can avoid select all, so always select only the necessary columns what you wanted to select. Don't select the unnecessary every column when you are selecting. So eliminating the unnecessary data is also by which it will invoke. Okay, I'm telling the best practices. So when you are reading dates, these you could have looked into that. And you know, uh, you need to optimize joins. So you can actually whenever you're using broadcast join, as I mentioned, or short merge join is also there. Okay, so or broadcast join. Okay, so we can sort the last data set before joining, and that is how it will reduce the shuffle. So it will reduce the shuffle in that regards. Okay, then you know about UDF? Are you aware of UDF? I have given the documents. Have you got a chance to look into UDF? user-defined functions? Hello?
I didn't look into those UDF functions, Dipesh.
In data, the document I have shared now, and there is UDF is there.
Okay.
So yeah, so UDF is nothing but it's a kind of a defining your own function, user-defined function. So in PySpark, it's allowed us to create our own, functionality basically, a natively supported Spark functionality. So whenever you defined your, you can import from here. Let's say you're importing from PySpark dot SQL dot functions dot UDF. Okay. And once you do that, then you can, once the UDF got imported, you have imported UDF, okay, then you can define your own, stuff like you are defining, let's say called def. This is the Spark functions, okay, def x return, uh, okay. So when you are defining from your own function. So you are creating like this. So you're the square of is this nothing but UDF, user defined function, is square into it should be an integer type. So it's kind of a defining a PySpark user defined function. So like we defined over there in Python, similarly PySpark have their own user defined function. So user defined function being used in Spark for any other kind of functionality you want to create. So that is how that is called user-defined function, and you can do look into that. But UDF help in multiple things when you have a certain thing to be organized into the certain task need to be done for a number of time. But there is a performance consideration we also look into that. UDFs are less efficient. So we should avoid you creating UDFs, okay? Because it's a you know when it's doing this processing, this it's actually when the serialization happening on the top of it, the data transfer happening on the top of it. So like it's make it from wherever the resources it is utilizing it, it's taking time we need to create. So because it's work on JVM process and it's required the serialization, and then again it's deserialize the process to stop that. So instead of that, we can use some built-in function wherever it is possible. Like whatever the PySpark built-in function SQL is there, we will try to create some built-in function. But unnecessary until unless we are not required, we can look into that. Yeah, Bin, that is something about this UDF.
Deepesh, UDF is not specifically for PySpark, right? We can create in SQL also create a replace functions is there in SQL, Spark SQL, and also in Scala also it is there, right?
Yeah, I mean, UDF is the Spark feature. Okay. So, it's a Spark feature that is available inside the function of SQL, pyspark.sql.functions.udf. Okay. So you can utilize this UDF for, your as a kind of a user defined function. So that is the feature of Spark.
And also in if you use in Scala, this UDF, it will be slower, but it won't be much slower because it will use by default Java serializer. But if we come in Python, if you use UDF, it will do pickling. First it will do pickling. It will send to the driver. Driver will unpickle that, and it will
What I'm
pass.
saying, it is doing serialization and then deserialization process. So
Yeah,
that is
yeah.
again, it's taking time because the two connector of Spark and the Python, there is some JVM is addressable, and then it's
5.4 Python for Java connector, 5.4J connector with chalk, right? Yeah, that is the connector.
is getting utilized.
Yeah. Pickling is a overhead if you use PySpark UDFs. That will be very slower.
Um, Yeah, these are the features. Okay. There are more features. There are more features of this, but uh, these are the enough. So many things is there. If you more you will learn, more you will study. I will share you some documentation. You can check on internet. There are a lot of documentation you get on Spark UDF. I could have also shared you some documentation. Like there are a lot of things. It's not while you experience, you will also understand a lot of things like how to handle skewness, how to optimize the data loading and filtering, how in what way you read the data in certain serialization process. I will create one Spark configuration for you that how the best way you can enable the adaptive query execution or shuffle the partition up to 200 or how you can use Spark as serializer, how you can create some data and then you can create a data frame out of it. That's something you can do. And how you can handle the skewness of this, how you can repartition the data by handling the skewness, how you can avoid UDF or how you can use built-in function. That's something you can look into that. How you can use broadcast join and how the broadcast join perform, how the cache result work. So these things you could have look into that. How you save the data into Parquet file. So these things are there that in one can actually look into this. Okay. These are some basics of the Spark optimization. Okay. And the next, I will be going to give you a kind of I'll be going to share you one problem statement. Yeah. So I was actually talking about um, how the different thing can actually look into. So I will discuss some kind of a performance evaluation technique and optimization technique. Let me just tell you how you can configure that, in real time, whatever I have discussed, how you can use those things. So for this, let me quickly connect. My screen visible to all of you, right?
Everything's your screen.
Yeah. So I was telling that you can set up first of all the configuration of your Spark. Okay. So your Spark configuration is important. Okay. And so here uh, like you do from PySpark dot SQL dot import Spark session, right? And then from PySpark dot SQL dot functions import column sum as Spark sum. Okay. And and then broadcast also. I'm just going to import broadcast variable. Since I'm going to can generate some random variable that can be for optimizing. That's all. So random, random function, right? Random is the function that will help us to you know look into multiple other things. So meanwhile, let's getting started. Okay, meanwhile, let me do one thing. Let me just generate some kind of a random variable so we can, yeah. So here I have a Spark equal to Spark, Spark version builder. Okay. Uh, dot app name. App name you can define like for Spark opt. Okay, then you can use, you know, yeah, that how you can define this as in config. So in concave, adaptive query education, AQE, there is a adaptive query, you can invoke. Yeah. So, you can shuffle the partition, you can serialize, those all things you can define inside this process. So here we're gonna do that, uh, you know, adaptive enabled and uh, let's see. So here I'm just going to config. So for this adaptive inquiry, when I'm doing it in Spark dot SQL dot adaptive dot enabled, right? And that's true. You can config some shuffle. Here you can config some spark.sql dot shuffle partition. Let me just create a shuffle of 200 and dot config. You can use Spark Serializer. For Spark Serializer, once I do this Spark Serializer, let me just search what is the org, I think. This is what org dot object is. This. So I can put here org dot Apache Spark Serializer carouselizer, okay? That we have enabling. Then get or create. Got it? So this is the configuration. This is what unexpected intent.
Dipesh, can you explain what each config parameter does?
See, first of all, I created the Spark app name, right? Okay. Then here, if you can see that I use this adaptive enabled. So this adaptive enabled is nothing but it's a kind of, while you are interacting with, your in a Spark. Basically, when you do AQE, so Apache Spark, designed in as such a way so that we can optimize some query execution in dynamic way. Okay, so when you enable it, AQE, so Spark make adjustment to the execution plan. Okay, during the runtime only. So it's improved the performance based on the when the actual data being processed. So like skewed data, so it's already, it's automatically addressed this stuff. So when we do dynamic plan adjustment with this, so it's the execution on runtime will happen. Okay, the data skewness detected, dynamically adjust the number of partitions. So that is just a Spark itself process.
We'll take care of it.
Yeah,
Okay.
it's a enabling. So when you enable it, then it's process. Then I did a Spark SQL shuffle partition. I did a partition of 200 here. I taken the set the shuffle partition. Then here I enable the carouselizer. I just discussed with you guys, right?
So in the above statements, you are asking to create 200 partitions for the given data.
Yes.
Okay.
Then once I did with that, once I define this, then let's create some random data. So the sample data generation. So for sample data, let's say so you might be aware of Python, so you might have used random. Uh, random dot rand and so 1 by let's say call 1 10,000 we let's say generate comma random dot end 1000 and comma okay. Here I can so here I take a random data random let me take some more columns for this so the 5 rows bigger data we could have generated in that case and some dates data also let me take 4
Dipesh, can you talk a little bit more about the shuffle partition?
no let me first work around it we'll discuss in this
The spelling of range is incorrect. RANG.
whatever question you will have you can ask me after I done with this okay
Yeah, sure. Yeah.
okay so we created some certain data here okay then you can see that this data is there let me also create some column for it so I can create a data frame so for this let's take the first column as transactions IDSA the customer ID product ID quantity price, and last one we use taken a date, right? So let's take a transaction date. Yeah. So here, let me create the data frame out of it. Schema, we can use the same of columns. So let me show you the 5 entries. Okay. Still creating. Taken so much data. Impact can reduce. You see that? Yeah. Now, instead of, like when you are data loading or you are doing, so we can only select the required columns and filter out the rows as, whenever, see, this is the optimization way of loading a data. So let's say the first technique, you know, like we can discuss is while you're loading a data, while exactly you're loading a data, you can load, instead of load the whole data, you can select the required column. So I can just do df.select based on certain thing like customer ID, quantity, or maybe price, and I can filter this based on transaction date. Okay. So when I do that, it will filter out all the unnecessary way. So it will optimize the process of doing that. Okay. So that is one thing. I think you understood this. Now the second is, you can write here load filter in optimize. Yeah. Next, we can talk about how to handle the skewness using data partitioning. That's what your question, Nikhil?
No, no, I was asking about the shuffle partitions. So I am aware little bit about shuffle partitions. This shuffle partition is used like if any narrow transformation is there, after that, if you have wide transformation, then it will split it as two stages. Okay. And each stage, previous stage, how much partitions it can create, so that next stage can take that. And like that, I have some information. So I just wanted to like get to know more about that if we have anything.
Okay, we'll discuss that later on. Okay. First, let me do this. So here, let's say if I'm handling skewed using data partitioning. Okay. So to balance the workload, we'll repartition the data based on customer ID, which is likely to cause data skewness in real world scenarios. Okay. So when we actually read the data using some certain thing, so here I can partition using that. So here when I'm doing this, so let's say call this is the partition data, and here I'm filtering df dot filtered dot repartition partition. Let's say I'm doing 100. So 100 based on column called customer ID. Okay. So when I do this, okay, so it is handling the skewness. Not to be filtered. Yes. Okay. Okay. Here. Oh, then we need a filter data part. Or you can use this. Yeah. So here, this will going to based on customer ID, this data has been taken up. Got the point? Let me create a filtered column. Quantity. Based on the where is USTONER customer ID QUNTITY price filter column. That's the mistake I made. Can anybody tell me?
This problem cannot resolve transaction due to data type mismatch.
Hmm.
It's a string data type, right? Data.
So we need to cast that, right? In that case, or I need to create a schema into put a filter based on that even.
In the filter, I think you have to give to filter with the date, we have to give some value there. Or what are we filtering with?
Filter based on transaction date column.
How, on what value it will filter?
We are selecting the column, no?
Does it have to be followed by a value?
Yes. Like you're telling that, okay, filter based on this column transaction date, but on what value it should filter, whether today's date or which date? I think that is what the error
Issue about
also is telling.
Yeah, I cannot directly do this. So wait.
So
Let
it's
me
like column transaction date equal to, you have to give some date. Then for that date, it will create a filtered data.
in transaction. Yeah, sorry, I'm confused. And here
Equal to.
I can maybe I have given till 9 now, so it will so much update. So I can take 4, 0, 1. I think it should work now. Yeah. So here we got, okay. So here, when I based on this data, I will partition by, I can do that. Or, you know, that is something I can repartition on this. And as I mentioned, we can use UDF column, or we can use some of the built-in function instead of UDF. So like built-in functions, so a lot of built-in function like group by with column. So we could have used that. By this, we can also uh, you know create a bigger impact on this processing. Now let me tell you the broadcast join with that. Broadcast join. So broadcast join, how can I tell you? We can take an example in which, mm, okay, let me create a lookup table, customer lookup. Okay, so here, let's say I have a customer one and customer A. Okay, and we have two
So
customer.
Deepesh, when you have enabled the adaptive query execution, right? So it does the broadcast automatically, right? Do we need to explicitly do?
So we are when of course when you are defining for a specific join, you need to define this now. So this when we are using adaptive query is like making throughout some join optimization it is doing, like it's switching between different join, like shuffle join, broadcast join, based on the size of the data runtime. But when I'm defining on a certain operation, okay, so you can define this for doing that particular join that you're doing for on a specific data. You can define this, but in by default also it is doing that in adaptive query. So I'm just telling you how this broadcast join actually work if you define by your own self. Okay. Um, so taking a customer A, customer B, yeah, and from the data that we have on the top, so what's the feature of this? Just a second, I'm not able to recall the function. I think it is, let's say, uh, for this I need to have a kind of based on some of the joins. So I need to create some more structure of data. Broadcast. Okay. Yeah. So this is how you can join, right? So for this, I need to take a data on this, a small data, I need to take. So this is using SQL. Okay. So in our data, let's say I have built, let's say, let me create a small uh, data that's called, let's say, revenue data. And in this, let me partition based on column quantity. Multiplied by price. So we are creating a new column, so we can do a broadcast run. Yeah. And let's do one thing with grouping by the data. So the total revenue, we can define that with this dot group by based on customer ID dot, let's say, aggregation. Revenue. Alias it. Yeah. And then based on that, I'm just going to create this DF customers equal to spark dot create based on the smaller table. Let's say and we need, let's say, call, okay, based on this data that I have created, customer lookup, and the schema let's define for this is based on our customer ID. Are you getting me what I'm doing here? Hello? So what I'm trying to do that is I'm trying to add the smaller table into this, the larger table. Hello?
Dipesh.
So this is my smaller table that I have just created. And with the larger table, I will do a broadcast run. I will perform here.
Dipesh, can you once print that DF customers just wanted to see the data, how it is coming there?
Okay.
Data frame you're creating, right? DF underscore customer based on this lookup and schema.
This is just like we have created on the above, right? So
Mhm.
should be got it.
Okay, so only the two rows that customer lookup what we have created, we are creating a data frame for that.
Correct. And then we will
Okay.
be joining.
Okay, got it.
Here I will do the result of both result DF What's our total, no?
Yes. Total join with TF.
Total dot join broadcast with DF customer. Customers. That's on by customer ID. ID left join. Let's do the left join. Left. Yeah. So this is the result. Check. So this is your lookup table that is you have tried joining with. You see that guys?
So Dipesh, here in the broadcast, how do we check the performance if we have to compare if suppose we do the normal left join without the broadcast?
You have to check the performance. Either we go to the Spark URL, okay, and then either you see the partition timing. And there are 2, 3 ways we do this. You can much time it has taken is this is a latest trend, right? Look, 0.3 sec. But if you try this without using that, without even calling this, can you please try and check? Let me share this with you guys. Please check out. Share. Let's do the join without this and without broadcast join and do a normal join. Can you all please try? Hello.
Dipesh?
Please try the broadcast join, the normal join, and the broadcast join, and check in the UI the timings and all. So and somehow how much it is processing. And then there are some other methods also. By writing some commands, we can also see the timing, how much time it has taken, and how it is. So we can check number of things. in Spark you use this in stages tab. Please check this. When you run this in the stages tab, okay. All the things, resource utilization, metric, and everything, please check. Did you get what I just asked you to do that, all of you?
Right, they could using normal join and then broadcast join.
Check the metric in Spark UI. There is a explain plane here. Here we did expansion. Yeah, did you get a chance to look into that? Hello? Hello?
Yes, Dipesh.
Working?
Yeah, we are not seeing any much time difference actually.
Course, not much difference you'll see because the amount of data is not so much. Okay. But it's going to make major impact when you have a huge amount of data and no. Okay, so apart from that, okay, let me just do one thing. I'm just sharing you one complete detailed project. Okay, I want you this as a thing you all have to do. If my screen is visible.
Yeah.
So see what you need to do that you need to do a complete ETL processing and a complete data transformation like I have done on pandas. So here I have done using pandas this complete problem statement. Okay, I have filtered, I have did everything. I did visualizations also. Okay, complete visualizations also. This visualization I want you to access on Databricks. Okay. Okay. As well as this something date wise you can do that visualizations and all. Okay, this kind of complete visualization you can use that using Databricks dashboard. Okay, then the problem whatever I have solved using here, right? Mortality rate, recovery rate of this data. I want you to explicitly look into this. Okay, and then some kind of a ML pipeline also. Like I have done the regression. I want you to do this using this mlib. Correct?
So Dipesh, are we going to cover any other topic today or
This is the all.
your voice is low, Dipesh? Can't hear you. Hello?
Audible better now?
Yes, yes.
This is what in Databricks that I was supposed to gonna discuss as per the requirement. And this is the problem statement I given. I want you to go through and ask me if you have any doubt in the problem statement to understand. So I can help you with that. Apart from that, I can take few questions from your side. If any one of you wanted to discuss any specific thing, you can discuss. But this problem statement will come back in this coming after it. I want everyone should have this solution, proper solution. And you can use all the techniques on the top of it. Like you can use, certain, I given you data sets, I given you some transformation process, I given you the ML pipeline. You need to apply everything. And apart from that, I want to create a medallion architecture where you can use the transformation process. After ingesting the table, try to for analysis or further later on create into that format. keep in mind utilizing the optimization technique also on this data. So that is the idea behind to give you this case study. Understood?
Okay.
If anyone have any
So
specific
today it is the final class for Databricks, right?
questions, correct.
Okay.
Yeah. If you want to have a discussion and question, specific you have, so you can ask me.
Okay. Thank you.
Um, Deepesh, one generic question.
Mm-hmm.
What are the advantages and disadvantages of creating a new workspace
New workspace.
from a project perspective?
Workspace is something, it is attached to the resource management, the complete resource management where you are accumulating a complete new project, new dimension of a project. You can create multiple notebooks inside the workspace even though, but workspace of Databricks is having a complete UI or the functionality of Databricks. So workspace creation, it's necessary only when you have a certain agenda for a complete entirely different department.
So
Because
that's
it's
so the compute power that we selected, workflows that we created, the catalog that was created, those are all tied to workspace, right?
Mhm,
So if you get a new workspace, you have to create all these things again.
correct, correct. You can create multiple workspace. Let's say somebody is working into the dimension of your manufacturing department inside this is working on certain ETL jobs. They have a certain very different department they are working. So they can create their specific workspace on the cloud. Okay. Similarly, a department that's working into certain field can create another workspace. They can collaborate if they wish on a certain ETL job they want to collaborate, then within the workspace they can collaborate. But creating a workspace is a entirely creating as an infrastructure for you.
Mm. It's like setting up a new network.
Correct.
Any questions from any other person? Uh, Deepesh, is there any document for better coding standards in Databricks? I know you provide as optimization techniques.
Mhm.
Apart from this, are there any coding standards that you guys generally follow while writing PySpark code or SQL code?
See, I need to check some specific document. I don't have any. I just actually try to sometimes follow the some Databricks guide, help guide. There are a lot of things they used to keep update. Okay. Uh, or generally we follow some reference codes. Okay. Reference codes, optimized reference codes that's sometimes available over the open source. That's also sometimes helps. And totally with peers, we learn from certain peers also that how it's happening. That's how like I updated myself. And the best way to look into that, there are some online books available for that. Mm, some of the books like mm, you know we call it, you'll get some books. I can share you those PDF.
Mhm.
Some of the books of, uh, I forgot the name of those. Some Pearson books, or not Pearson, what's the name? I forgot. So those books I have read some documents in my past. So that is how I would have my material with me, some other folders over there where we can look into that.
Okay, you have some notes where you, from your experience, you consolidated those learnings into your notes.
Yeah, yeah, that is how, it helps. It's
Mhm.
actually helps sometimes, but majorly, it's totally throughout the experience. Throughout the experience, there is a lot of learning happen, by doing and again and you know, getting the stuff done in an entire different manner sometimes.
Okay, so you mentioned Databricks guide as one of the reference points. Is it published by Databricks organization?
What?
You mentioned Databricks guide.
Yeah, correct. Databricks used to mention you can get their reference material if you go to their Databricks reference material. Uh, you know, so can have a look here. But in learning lot of things are there. Yeah. So here a lot of codes, videos, materials, work with database objects. So you'll get schemas, you know, everything how the schemas is there, what is database, with some examples, codes, a lot of things is there. So that way you can actually look into that. So database keep adding their videos and multiple other stuff
Mhm.
on top of it. You can search any specific document.
Delta Lake.
Mm. So you can see that it's an open source, so people also sometimes post configure Delta Lake on control data file size, optimize how it is running executors, traditional write, optimize write. What is the process that we were doing in there? It's you need to keep looking to that. And since we are a trainer, I'm a trainer from so long now. So what happened? We actually see after a certain point of time, they keep upgrading a lot of things.
Mm.
And that's why, you know, if you are not a developer, until unless you'll not be very, very frequent to see into these things. Uh,
Mhm.
so they make changes, they make a lot of changes. Previously there was no catalog directly. Now they added catalog, means the data, the way they mentioned everything. They make some changes over there. You need to quickly look onto their eyes.
Dipesh,
Yeah,
are there any challenges with Databricks?
challenges in terms of what?
For example, initially it was map reduce concept, right? Map reduce is not sufficient. That's why we have Spark. Spark is not so efficient in some aspects. That's why we have Databricks. So are
Yeah.
there any challenges current Databricks framework has?
See, it totally depends. See, if you have ever got a chance of working with Informatica,
Hmm.
you might have seen this Informatica is more user interface based.
Mm-hmm.
Okay. So here you need to do a lot of programming thing.
Mm.
A little bit cost management is also a challenge because we are running the multiple clusters and all, for auto scaling. So some cost management challenges are there. And of course, the major challenge is like integration with other tools as of now, even though the compatibility checking with the different databases, data lakes, still there. So yeah, managing the data are also one of the part that. And yeah, one thing since there is no unified support system as of now, you know. So, so if it's not a unified support system, so that's why
What do you mean by
documentation.
unified support system?
Uh,
What do you mean by unified support system? Databricks is not good with support.
Support system means, uh, you know, they keep changing their user interface and multiple other things. For that, they don't add much documents.
Mm-hmm, mm-hmm.
What I'm using 3 months back, 2 months back, the Databricks. Suddenly, when I open in another 1 month, I see a lot of changes.
Okay,
UI got
so it's
changed.
evolving.
Support changes, support documentations missing.
Mm.
And
Okay.
that's how you realize, array, I was doing this way. And now,
Mm.
even in this, when let's say I am before 1 month, I was using something else, it suddenly changes something. And then I have to look
So
into
relearn. Mm.
learn. So these support changes are and the development and the guides are a little bit not available very frequently. So this is one thing.
Okay. I mean, are there any other products which offer same services as Databricks?
Yeah, of course. Like Snowflake is there.
Mm.
You can use IACS tools nowadays, Informatica.
Mm-hmm.
So Informatica IACS can do almost a lot of things. Uh, that is data query. That ensure a lot of things over there.
Then in what parameters does Databricks stand out compared to their
They are
competitors?
like a developer people tools, when you are having a good programming skills, when you have a good, like good hands-on of programmatically sound you are, then Databricks something, and you are more well working with very, kind of in a more IT friendly group of people where you have a lot of these kind of associate peoples are there. So then Databricks is very useful because you have a lot of freedom over there to
Yeah,
tweak your data, to munch your data.
Hello, Dipesh. If we compare the performance of ISCS and Databricks, so who stands better in this case?
IICS is comparatively different tool, but doing the same thing. So IICS is, recently they added IICS cloud version of Informatica. Before that, they had Power Center or IMDM, or they had some other tools also. So when they added IICS and, if I consider Databricks, so IICS is like a user interface tool where you can directly select your data, you can do a maplets, you can define that. So data management, I compare Informatica intelligent cloud services. So that's not just have only this, but the management part here is a little more better because you can do data quality, data governance, as well as application integration. You can do easily data integration. You can do that. Whereas data bricks are more primarily used for data engineering, data science, analytics Delta Lake. So these are the features. So when you are more into the management side, when you are more into the quality side of data or governance side of data, then you go to the IACS part. Whereas Databricks is more like data science, data engineering, where you are just doing ETL and all. Okay. If Databricks is replacing IAC, Databricks is replacing SSIS, SSS tools.
Mm-hmm.
Getting my point?
Mm-hmm. So Databricks is replacing SSIS and Pentao, you are saying.
Yeah, means that is the advantages over cloud of Databricks.
But like IICS will also do the same thing, right? I mean,
ICS having major other property also. It's have MDM tool also, master data management tool also. It's have data quality tools also, advanced profiling, cleansing, enrichment process. Application integration, integration is more smoother, easier on the top of it. So it's far better in those things. So when you are not looking to do data science project with high amount of data, when you're not looking to do advanced ETL processing, yeah, of course you can do ETL processing, but when you are more like a management side of data, then you can comparatively use that tool.
okay.
And I have seen there is a certain industries are majorly using, like telecom industries are highly using IICS. Uh, I am going to Hyderabad next month for this IAS training only. So that is also a telecom company. And so majorly what I have experienced, telecom companies managing their almost their data using ISTS tool. Not just telecom also, but it's totally depend on how marketing is there. Marketing people are also approaching in certain way to certain features and all. So uh, that's also drive sometimes. Of course, there are for same thing we have multiple tools. Snowflake is there, Databricks is there, ICS is there. Um, you know, uh, I will say, ACL is there. Have you heard about ACL? ACL is also doing the same thing, but for auditing and multiple other focused area tools. So that is how you will find a number of tools in industry.
Okay.
Which provides better integration with other tools? Is it Databricks, Snowflake, or IICS?
ICS. But in when you talk about Databricks utilizing using Azure will enhance the process in a very faster way, or AWS other services. You need to create pipeline using Databricks. Okay. In IICS, you don't have to create pipeline. IICS itself have their all their services as in pipeline. Are you getting my point?
Yeah.
Here you need to create a pipeline, like you need to use Azure Data Factory, or you need to use to manage the whole orchestration. You can use EMRs or maybe Glue or maybe these kind of thing, or maybe you can integrate with, uh, you know, something. So when you see the Azure data pipeline with Databricks, so you are managing or orchestrating all the process flow using Azure Data Factory. You are storing the data into Azure data blob storage or Gen 1, Gen 2. You are using data warehousing in Synapse Analytics. You are using, and then in between Databricks you are using for ETL or maybe for Delta table. So that is how the pipeline been created into that. These are highly available pipeline, but the dependency is much here, right? Whereas in Informatica IICS, you have a major dependency on IICS, and the data storage you are using is either from S3 or from any Oracle database engine, or maybe from MySQL database engine or SSIS engine. You are ingesting the data, moving into that certain format. You are making all the changes over there, and then again and doing MDM or storing the master data management, or doing the data governance, defining the roles, responsibility, role-based access management. So when it come to the higher management side, who gonna access what kind of data, okay, how the whole process will happen, there the smoother version of ISCS is there.
Okay. So in Databricks, we have this role concept, right? For providing access.
Yeah, we can also do this access management here, not just by Databricks also, but you can define the role-based access management by IAM access of the cloud as well as.
Can we do it over Databricks? The role concept.
Which one?
In Databricks, can we create different roles to provide the access to specific sources?
Yeah, that is why a key concept of RPAC we can define in Databricks also, no? So, how much resource you wanted to based on roles you can define. So roles and permission is there. Databricks also have predefined roles, but in IICS, even
No, no, let's stick to Databricks, Deepesh. So in Databricks UI, I don't see any provision or any link to create new roles. Or am I missing?
settings, when you go into that setting, yesterday Nikhil was showing us, no?
Hmm?
Nikhil was showing yesterday when the people came, the lab people came, in
Hmm?
settings, you can define multiple user to access that in the premium version. Might have seen that.
Okay, it is only for a premium version. It's not
Yeah.
available in cloud community.
Yeah, yeah. No, 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 no. Because it's for one worker only.
Okay.
Yeah. So you can grant permission, you can create workspace admin, you can give cluster permission, you can create cluster policies. Those things can be done here also. Even you can give a folder permission, notebook permission. You can define those roles.
You have the premium account with you, right?
Not now. I have not created for today.
Yesterday you were using the premium account. Premium account.
I was using, but today I have not created the AWS workspace on the top of it. Can you share? I'll show you where you can.
I don't have. Nikhil, can you share your screen?
Even I also didn't create that workspace. I'm also using community today.
Okay. Can you log in?
Sorry?
Can you log into the premium account?
Let me see. I think still we can use this account. We can't start the cluster, right? Still we
Okay, can you show them in setting, Nikhil, something for active permission settings and all?
So this is the workspace settings.
Yeah.
Hmm.
User setting. This is specific to the current user. If we have any GitHub access, if we want to create, then we'll go to the linked accounts, all those things we user specific, and this is workspace specific. And only workspace admin can access these things. Workspace admin who was in, I am the workspace admin. Only one user is, so I can able to access. Here inside this, there is an identity and access section. Okay, inside this. Okay, inside this, we can create new users. We can add the user. Once we add the user, they can see empty, means no resources. They can't see anything. In after adding the after creating the user, we have to add to the groups. Okay, there are two groups, and I can create a new group. Okay, maybe dev group. Yeah, dev group, and
This group is nothing but role.
now here we have to give permission. What level of permission user can access inside dev, right? I can add permissions. Okay, this is in preview. I don't know. Maybe there's some new feature added there. That's the reason they added in preview. But we can grant the access. What kind of access we want to say, and let's say uh, okay, for which group, what are the access? So I think we have to create a group manager.
This is role.
We have to create the roles here. And also we can add the members, whatever users we created there, right? We can add the members, and any instance profiles users can use attach in that cluster, we can add here. And if any from parent, if any other group we want to inherit all the properties with that, we want to add additional, let's say like we are creating stage. Okay, there all the dev access plus another means view access is needed, or like in like that in vice versa also, there we can give this kind of information is available here. And also in instance profile table level access control, we can select create modify. Yeah, these are the things are available. I don't know that much detailed this one, but I just know little bit about these things. Yeah, and also we can enable notification surveys and uh, who can create access means we can peoples can create access tokens, pat tokens, all those things are here. Yeah, this is for logging. Okay, if you enable this, it will do audit log information, it will store. If you do cluster
And
log, different log.
where do we access those logs?
Sorry,
Where can we access those logs? Let's say we enable logging, audit logs. Where can we access them?
I think it will directly go to S3. S3 like wherever we create the workspace, right? When
Hmm.
S3 folder will get created, okay, specific to this Databricks workspace. So Databricks won't store any information. It will store all the information in S3 and it will extract when you open the console to extract from that S3, okay. And if we add if that, it will create an additional folder maybe and it will add the data. It won't store anything here. It will store in the S3 only.
Okay.
Also, if you want to enable DBFS, now I can't see DBFS. I can enable this and we can see that. So these kind of features is there. Yeah.
These will get on a help section now. Everything, and there's updated stuff you can get.
Help section, like what I'll suggest is if we are not if maybe we are using AI tools or something, okay, it won't all AI tools won't give proper results because Databricks is specifically designed and it was always evolving. If you use OpenAI something, okay, other AI tools, it won't give proper results, to give complete wrong results. So whenever you want to add something to Databricks, either we can go through documentation or we can use this assistant. This assistant will be trained using Databricks documentation. So it will give accurate results than other things. So we can use this assistant. That is also one more thing. Instead of any AI tools we are using for Databricks related, if I want to ask any services, you can use assistant. It will give more proper results, answers. I mean.